In this problem, I will talk about weighing a baby or an object in an elevator. Do not try this one with your baby. You can choose any other object. And I urge you to try it by taking a spring scale and put a mass onto this one. Measure the mass first at the ground and then measure into the elevator. You will see two readings, whether it is going up or it is going down. And just by measuring the two readings for up and the down, you should be able to calculate the acceleration of the elevator. Let's talk about how do you do that. So here I've chosen one particular number here. A father is weighing a baby. First, he measured the weight of the baby, which is 40 Newton at the ground, or when the elevator is at rest, 40 Newton. And then if he is trying to find out the weight of the baby, what is the weight of the baby if the elevator is moving with 3 meter per second square. And then he is again measuring the weight of the baby when the the elevator is going down with an acceleration of 3 meter per second square. And also find out the weight of the baby if the cable breaks. So this would be disastrous, okay, if the cable breaks. So the weight of the baby at the ground he measured is 40 Newton. So from this one we can calculate the mass. The force or the weight is m times g, and this is equal to 40 Newton, and the mass is 4.08 kilogram. That's the mass we found. Now let's say the elevator is going up. That's the situation shown here. When the elevator is going up, the reading would change. Why does it change? Because we feel our weight, because we get a normal force from the earth's surface. It is the normal force that makes us feel like we have a weight. Okay, that is that. And when you put a mass into an elevator, because the normal force would change whether it is going up or down, the sensation would also change. That is called apparent weight. And we can, by using Newton's second law of motion, we can calculate what is the weight of our body or whatever you're measuring inside an elevator. So let's say this elevator is going up here. So we can write down the Newton's second law of motion. What does the Newton's second law of motion tell you? The Newton's second law of motion tells you the force, the total force is equal to mass time acceleration. And in this case, the total force is the tension minus mg. That's what I have written here. And this is mass time acceleration. And it is the tension that is our apparent weight, or the weight of the baby if you're measuring onto the scale here. So the mass does not change whether you measure into an elevator or onto the moon or onto the Jupiter. The mass does not change. What changes is the weight or the apparent weight. So the mass remains the same, which is 4.08. Acceleration due to gravity is 9.8, and the acceleration of the elevator is given, which is 3 meter per second square. And what he measures is 52.2 Newton. So you would see the different readings here, 52.2 Newton. And now again, apply the Newton's second law of motion when the elevator is going down. So how do you write down the Newton's second law of motion? Again, the same formula. The total force is equal to mass time acceleration. And in this case, the total force as the system is going down, the way we write down is mg minus t. You see a very subtle difference. When it is going up, we write down t minus mg. When it is going down, we just take this force minus this force. When it goes up, we take this force minus this force. So for going down, it is mg minus t equals to ma. And then t equals to mg minus a. Mass is given 4.08. G value is 9.8. A is 3. If you solve it, you'll get 27.7 Newton. So you see, when it is on the ground, you read 40 Newton. When it is going up, the weight increases. You'll feel a lot more weight. And when it is going down, you'll feel less weight. That's exactly happens even in the aeroplane. When the aeroplane is going up, you'll feel a more normal force. When it is going down, you'll feel less normal force. That's exactly from the Newton's second law of motion, or your apparent weight is changing. Now what happens if the cable breaks? If the cable breaks, the elevator starts moving down with an acceleration of g. So A would be exactly equal to g. So what I'm going to do, so in this equation, I'm plugging A is equal to g because it is now going down. So this equal, the total acceleration would be 0. Excuse me. G minus z, and this is equal to 0 Newton. So the scale will read nothing, 0 Newton. That is free fall because there is no any normal force acting onto you, and the spring scale would read nothing. So this is it for weighing a baby into an elevator. Again, if you have any questions, write down your questions in the comment section below, and do not forget to like, share and subscribe the channel.